Now, let's take a look at 10.3. 10.3, it is about changing state. So what are the things that you need to know in changing state? Will be, first things, you need to know some things we call it as a heating curve. Before I go into a heating curve, let's run through the basic that you guys have learned. We have some things we call it solid, and then we transform it become a liquid, then we transform it become a gas. So we know that from solid to liquid, we call this as a, yes. From liquid to gas, we call it as a, yes. Evaporating. What about if it is a gas to liquid and liquid to solid? Gas to liquid will be yes, condensation, and then liquid to solid will be, yes, freezing.
Yeah, I might do this one.
Yes, that's the one that whenever is going from solid to gas, we call this as a
sublimation.
sublimation. So an example of sublimation. Do you know what is the example? Do you know what is the things that go from solid to gas immediately?
Dry ice.
Yes, dry ice.
Wow, tembak mana?
Huh?
I tembak the answer.
What do you say?
I simply say only.
Huh? I thought. Yeah, it's dry ice. Dry ice is the only one that going from a solid to gas. Therefore, if you go and buy Baskin Robbins and you take away, they usually give you a dry ice, a pack of dry ice. That is what we call as the sublimation. Go from solid to gas immediately. So this will be the things that we are thinking of. The second thing is that we will look into a little bit more compare between evaporating and then another thing compared to boiling later. But now let's focus on our heating curves. When we talk about the heating curve, there will be always two components in here. So whatever things that on here, it will be a temperature. Whatever things that on here, it will be in time. I mean, I don't put in a unit because you can compare the stuff in terms of second or in terms of minute, in terms of hour, it can be anything, as long as it is in this zone. So when we look into a temperature and a time in terms of heating curve, a heating curve is increased in temperature, definitely, right? So that when we increase in temperature, we will have curve something like this. We have something like this. This is a heating curve. So what I want you to notice here will be, this can be in 0 degrees Celsius. This can be in 100 degrees Celsius. This one here. I put a 0 degrees Celsius here, not here, yeah, because we know the temperature sometimes can go -10, so I just put it around here. So in terms of heating curve here, remember just now we talked about specific heat capacity. And when we talk about specific capacity, we learn the formula of E equal to MC delta, or sometimes you can write it in terms of MC change in temperature, right? Either one. So what does the specific heat capacity tells you? It means that whenever you have this component and this component, it means that there is a change in temperature, correct? So always remember, specific heat capacity only appeared when there's a change in temperature. That's fixed, okay? So where in this zone here, where is the situations we have a change in temperature? The first one is this one. This curve here tells us that this straight line going up tells us that it's solid. This straight line here tells us that it is a liquid. And this 45 straight line, the last part tells us is a gas. So this three component, it is where you use a specific heat capacity. Now, pay attention. Let's take a look at this line and this line. Is there any increase in temperature? No, when there's no increase in temperature, this is the zone where they don't increase in temperature, But where is the heat being used? The heat is being used to break the bond in between. Therefore, in here, it is your solid plus liquid. And we also call that as from solid to liquid, we call that as a. Therefore, in this zone, we call that as nothing. Whereas this is a liquid, this is a gas. So in this zone, we call it as a liquid plus gas, correct? Liquid plus gas, we call it as a evaporating or boiling. It can be two different things, yeah? It can be either evaporating or it can be boiling. If you are using fire to heat up, then we call it as boiling. If you let that for a long period of time, that is what we call as evaporating. But in this situation, let's assume we are using boiling here. Will be easier. Okay? Let's assume boiling because a lot of time you don't experience 100 degrees Celsius in weather. No. Therefore, a lot of times that we use a boiling rather than evaporating. Okay? So now you know that in this zone already. So why sometimes the questions will ask us, how come that there's no increase in temperature here? How come there's no increase in temperature here? The reason is because heat is being used to break the bond. That is the things that you guys need to know how to answer. So let me just write down my fact. Heat is used to break the bond. Okay? Yeah. So this is what we call it as the heating curve. Then once we know that the heating curve, of course, we will have a cooling curve, correct? A heating curve is just reverse of the cooling curve. Heating curve going up, cooling curve will be coming back down, reverse of it. It's the same thing. You start from gas, then liquid and gas, then liquid, solid and liquid, then solid. So it's the same. So I don't draw the cooling curve. But then now the next thing is that I want you to compare two things. Remember just now here I said evaporating and boiling. You need to know what are the things that's between the two. Comparing boiling versus evaporating. So what is the difference between the boiling and evaporating? There are a few things that you can point it out. Number one, boiling only happens at a specific temperature. If you want to boil water, it must be 100 degrees Celsius, specific temperature. Whereas evaporating, there is any temperature. That is the first difference between the boiling and the evaporating. The second thing, boiling happen. Sorry.
Takes shorter time.
Shorter time. Yes, you can. No, sometimes boiling it needs a longer time. When you boil water, it will sometimes take a longer time. So the next thing that,
Bubbles.
Yes, boiling, bubble exists. This is beautiful. And then this one, no bubble. Then there will be last one. It will be boiling happen throughout entire liquid. When you see boiling, it's the entire liquid is boiling, whereas evaporating is only
surface.
Yes, surface of the. Okay, easier. There'll be one more one, but I find it's not so important. Let me just bring it up. I don't want to write down because you don't need to memorize it. Boiling, the kinetic energy tends to be higher than evaporating. Boiling is when you boil, all the particles is heating, therefore it comes out bubble. Evaporating, do you see bubble? No. Therefore, evaporating, a lot of time is the particle escape from the surface. You see the difference, yeah? But do you need to remember? No need. Usually this three will be much easier to remember rather than using the kinetic energy formula. So that is the three difference of the boiling and the evaporating. Then the next thing is that what are the factors that affecting the evaporating. So there will be a few factors. Number one, we can say that it is a temperature. Temperature, of course, it will affect the rate of evaporating. So basically, when temperature increase, evaporate faster. Second thing, you talk about surface area. So when your surface area increase, it will be the same as evaporate, it will be faster. Then the third thing that we talk about air or wind, we can call it as wind. When there is a wind increase, it will evaporate faster. Then the last part, we call that as a, you guys know what is humidity, right? Okay, so we know that humidity, when the humidity decrease, therefore it will evaporate faster. Because when the humidity decrease, it means that it's dry. So whenever it's dry, it's dry, therefore it will actually evaporate faster. So that is the four components that affect our evaporation. And that is the end for the chapter 10. Okay, yes, you can.
Yes.
Okay, I will stop recording, take a photo and send it.